This is more log, so in some ways it's good. It'll strengthen, because there's logs on today's test. This will strengthen more of your log knowledge. So log base 3 of 3. Oh, there's nothing on the screen, huh? This thing's so sensitive. There we go.
Wait, what? 5.5 is due October 12th?
All right, so let's take a look. So log base 3 of 3 to the 76. How do we do that thing? Any ideas what the answer might be? It's kind of weird. It's like it's got 3 layers there.
It's weird.
Well, here's what we can do. We can just go equals x. It's like naming a pet. Just say whatever you are, you're called Rover. Whatever you are, you're x. All right. Okay, now, what are we going to do from here? What's the fundamental rule of logs that we have learned? What happens, for example, when I cross off that log? What happens? Every time you cross off a log. The base stays the base, the other two switch. It's almost like a song, right? I hope it's ringing in your ears because you'll use it today on today's test, right? When you cross out a log, or by the way, gain a new log. Either way, same thing, right? Remember when we translate in or out of the log language. That's the fundamental log rule, right? When you put a new log on that wasn't there before, or you take one off that was there, translating in or out of log speak, log language, right? Either way, what happens? The base stays the base. The other two switch. So that means, who's the base? Who's the base here? Who's the low down one? Well, clearly him, huh? He's lowered down. So he's the base, and the other two will switch. Now, what are the other two? It just means everything else, doesn't it? It means all of that and that. They switch positions. Instead of that low down 3 to the 3 to the 76 stuff, it'll switch positions, and it'll be the low down 3 to the x, and the 3 to the 76 will go over there. Right? Isn't that the fundamental log action? And cross out the log, base stays the base, other two switch, and then you tell me, what's the answer? What does x have to be to make that true? Yeah, by clear, as we said in grad school, we used to say clear to the most casual observer. Right? X has got to be 76. Good? On that? So it's really just to cross out the log. Put an x on the right side, cross off the log, do the normal log step, base stays the base, other two switch, and the answer becomes obvious. So, having observed that, now that we've done all that formality, do you know what you could do? And you probably guessed that answer beforehand, huh? Basically, when the base and the what's called the argument match, they effectively cancel each other out, and the answer is just 76. So if you want, from now on, if you recognize that, you could just cross them out. That'll always happen. So, for example, if I had log base 2 of 2 to the 10th, what's the answer going to be? Just 10. These guys will cancel. So if these two match, if the base and the thing that comes next, called the argument, match, they're just going to cancel each other out. Why? Because remember what a log is? You know quite well now. It's an inverse exponential, huh? It's a reverse power, so it undoes. Right? So if you had log base 3 of 3, well, that's what we just did was 3. Huh? Try and do something different. Log base 8 of 8 to the whatever, 17. That'll be 17, won't it? They'll just cancel each other out. I mean, you could prove it with all these steps, or you could just do it. That's always going to happen. When the base and the argument match, they cancel. Okay, so with that in mind, what do you think is going to happen here? ln e to the 18. Is this e the base? No, he's not lowered down. He's just another, he's on the level, isn't he? So that means there's what? Another e, an invisible hidden e, which is always really the base, the low down number on an ln, natural log. It's an L, right? Tyler, just giving you a hard time, man. All right, L in there. Did you go back and fix those? Was that good?
I couldn't find it.
Oh, okay. Anyway, so what happens? What's the answer to this problem? Just boom, 18. They just cancel, huh? I mean, you could do the formalities that we did last time, put an X and lose the log, and, it would work out the same. It's just going to be 18. Make sense? On that, we good? With all that? All is well? All right. Okay, so 5 to the log base 5 of 3. If you were just to guess, what do you think the answer is? 3. It is 3. Now, it's fine with me on a test just to say it's 3. Why? Because the base and the log base match, so they're going to cancel. It's going to be 3. Now, that's not really a proof. That is the answer. Let me prove it to you also. I don't know if you're like me. I like to see reasons for things. But on a test, it's fine if you want to just do that. Let me go over here and give you a proof, so to speak, like why it's really true. Why is that? Because that's a little different than the last couple, huh? It's kind of reversed the way it's set up. Why is that really true? Well, how should we do it? Why don't we go equals x? Just put down an x. So whatever it is, it's x. Just calling it x, naming your pet there. Okay. And then what I could do is I could bring in a brand new log word, an extra one, to the front. That's what I could do. So I'll say, okay, I'm going to put get this out of the way, put a brand new log word in there that wasn't, in addition to the one that's already there. Does that make sense? I'm going to put an extra log word there. You can do that anytime you want. Anytime you want, you can change something into the log language. Okay, so what happens when you do that? What happens when you put in a brand new log word that wasn't there before or remove one that was? Base stays the base, other two switch, right? You with me? Either way. If you put everybody catching on to that? I hope that's real clear. Whenever you put a brand new extra log word that wasn't already there to the front, or remove one that was there in the front. Either way, you're translating in or out of the log language, and the action that happens is base stays the base, other two switch. So, the base stays the base. Who's the base? Well, that guy. He'll continue to be the lowdown, the base, right? The base stays the base. The other two switch. Now, what are the other two? Everything else, meaning this guy and this guy switch positions, don't they? The other two switch when you put a new log word on there. So instead of 5 to the log stuff, it'll be 5 to the x, and the log stuff will go over here. Right? They switched. And now, what's x got to be to make that true? So see, it is 3. So that's the proof. If you like that better. Or you could just say it's 3. Powers, so again, when you got a power and a base on a log matching, they're going to cancel each other out, because that's what a log is a reverse power. Okay, so log base 12 of 3 plus log base 12 of 4. Oh, yeah, I need to show you the properties. Okay, so here, let me set this one aside for a minute. And let me write, so it's time for the 3 big properties of logs. You've probably seen these in algebra before. So the log base b of x plus the log base b of y. Wait, let me write the other way. Let me write this way. Of x, log base b of x times y is the log base b of x plus the log base b of y. So in other words, multiplication inside one log is adding for 2 logs. You've seen that before? Remember that from algebra? Yeah. Multiplying becomes adding. And then log, so number 2, change colors for clarity. So number 2 here, log base b of x divided by y. So if multiplying becomes adding for 2 logs, then 1 log divided is going to become what for 2 logs? Subtraction, huh? Log base b of x minus log base b of y. Remember that from your algebra days? Sort of, kind of, maybe? And then the third quality, the best quality of logs, log base b of x to a power is what we've already been using. That's the whole Stalin Hitler thing. The power comes down to the front. Log base b of x. That's the one we've already been using, right? We bring powers down. That's what you're going to use on today's test. One of a few log things, right? So there it is, formally now given to us. Remember I said I was kind of jumping ahead, grabbing that quality because it's helpful. Remember, it brings powers down. That power comes down to the front. So there they are. Those are the big three log properties. And we're going to, basically the whole section and everything else we do with logs is just going to use those properties. Forwards and backwards, and they're just going to give us all kinds of questions using those properties. So really you want to, you can put them on your 3x5 card for sure for the next exam. So you don't have to memorize them, but it probably will help you to just kind of know them cold because you're going to use them so much forward and backwards. So let me help you to know them cold. What was the first math operation you did when you were a kid? What's the first thing you ever did with math?
Plus.
You didn't start with dividing, right? You did adding. And then you did subtracting. Then you got a little older and you did multiplying and dividing. Then you got a little older and you did like powers and stuff, right? And that order is the PEMDAS order, right? Please excuse me, dear Aunt Sally, or PEMDAS, however you want to say it. You know the order of operations? There's a tie-in between that, how we learned operations as we learned math as a kid, and the order of operations and what log rules are saying. And since you already know this, I'm going to tap into what you already know to show you that's all the logs are saying. Let me show you what I mean. So get rid of the P. We don't have any parentheses here. But exponents, right? That's exponents. Multiplying, dividing, adding, subtracting. The PEMDAS thing. What's going on here? Basically, this hierarchy of operations, PEMDAS, is the way it is. There is a hierarchy. They're not all the same level of importance because the higher operations repeat the lower operations. I don't know if you've ever, I'm sure you know that. Like 3 times 5, multiply, right? What is that? That is 5 added 3 times, which you know. I'm not telling you anything you don't know. Multiplying is repeated adding, isn't it? Okay? So multiplying is repeated adding. Dividing is repeated subtraction. How so? 10 divided by 2 is 5, as you know, because you can subtract 2 5 times out of 10. So dividing is repeated subtraction. And so multiplying is repeated adding, dividing is repeated subtraction. This level repeats that level. That's why it's higher level up, right? I can go 17 times 4, and instead of adding 4 17 times, which would take a long time, I can just multiply them and get the answer 68, I think. Much quicker than adding 4 17 times, right? So these operations are more powerful. They quickly and instantaneously repeat the lower level operations, don't they? And likewise, what does 2 to the third mean? It's repeated what?
2 times 2.
2 times 2 times. It's repeated multiply, isn't it? So the hierarchy of operations is because they're more powerful because they repeat the lower, don't they? 2 to the third is quickly repeating multiply, isn't it? So if you want to take 2 to the 17th on your calculator and hit the buttons, you can just multiply 17. That'd be much quicker than going 2 times 2 times 2 times 2 times 2 17 times, right? So the powers are like that. The levels are like that. They repeat. Now, having said that, what does that have to do with logs? Logs basically bring remember, they're reverse powers, aren't they? Remember what logs are? Inverse exponentials. What do? We see that in their qualities, their properties. They basically bring all the operations down a level. If you'll just think that way, if you'll think about these levels, the PEMDAS thing, and you'll look at the log qualities and just realize they're bringing everybody down a level. Times becomes adding. See, it went down a level. Times became adding. Dividing was down to subtraction. Powers become multiply. Power was brought down to multiply. You see, the logs are just bringing everybody down a level in the order of operations, the hierarchy of operations. That's all those qualities are saying, is logs bring everybody down a level. Not only that, let me give you one more word of memorization help. They always, because it's easy to get it confused which way it goes, so let me say this. You've heard of the old saying, many hands make the job lighter, right? A lot of people work on the thing. I helped a friend move this weekend, and he called and texted and said, I've got a 700-pound marble tabletop thing. I don't know why he owns such a thing. And I need to move it, right? And so I and a bunch of other guys went over there, and with all of us, I think there was like 6 or 7 of us, lifting it, it wasn't bad at all. No problem. With a lot of people. I came home and told my kids, I said, I lifted a 700-pound table. I didn't mention the other guys at first, So that's a different story. If I tried to lift the 700-pound table, it wouldn't have gone so well, right? So many hands make the job lighter. That's what the log qualities are saying. Look at the log properties. So the right here, 2 logs, it's just adding. 1 log, it's a harder job, times. Do you see that? See how the properties are going? For 1 log, it's a harder job, multiplying, a higher level operation. For 2 logs, it just becomes adding. Same thing here. 1 log, it's dividing. That's a higher level operation. Then 2 logs, it's just subtracting. The job becomes easier for the 2 logs. The third property, he's just 1 log to 1 log. He's different. He's the special one. All right, so with all that said, here we go. So there's my effort to help you know these well. So let's look at this question. They're giving us log. Oh, by the way, notice the base never changes. All of those are log base b, right? We're not messing with the base at all. It's just the other stuff that we're moving around. The base is always the same. So here we go. Log base 12, log base 12 of 3 plus log base 12 of 4. 2 logs, an easy job of adding, becomes a harder job for 1 log, doesn't it? What do you do with the 3? And the base isn't going to change. Log 12, log 12, log 12, don't mess with the base. You take the 3 and the 4 and you multiply them. It's a harder job for 1 log, right? Adding becomes multiplying. And by the way, it makes sense that multiplying and adding go together. They both make things bigger. And dividing, subtracting go together. They both make things smaller, right? All right. So, so what is that? That's log base 12 of 12. Good to there so far? I just multiplied 3 times 4 is 12. And now what's that? What's log base 12 of 12? Remember it's 1. Remember we talked about if these guys match, it's 1. If you're not sure, you can do the formalities. You can say, you can put it equal x and lose the log and base to the base, other 2 switch. I'll do it real quick. But you don't have to. If you just see it, you go, yeah, I already know. When the base and the thing match, it's just 1. That's true. X, I'll do it formally here. X, and then what do? You lose the log. The base stays the base. The other 2 switch. 12 to the x is 12, right? These guys switched position. So what does x have to be to make that true? 12 to what power is 12? Well, 1. So there it is formally. X is 1. Is that good? Are we happy about that? Questions on that? Are you feeling tortured to have lecture right before an exam? Thinking, Mr. Heron, just give us that exam. We have to, sorry. 10 minutes, we have to. Okay, so log 530 minus log 56. Try that one. So use the properties we just talked about and put that into 1 log, right? Subtraction for 2 logs. Subtraction for 2 logs. Easy job. Right? Adding and subtracting are the easiest operations, right? The easy operation for 2 logs. Going to be harder for 1 log. But the base won't change. You never change the base. Log base 5, log base 5, log base 5. So subtraction for 2 logs is going to become what harder job for just 1 person? Dividing, right? Subtraction goes with dividing. Adding goes with multiplying. Is that good so far? And then what's that? 30 divided by 6 is 5. So what's that? 1. They're not all going to be 1, but a couple of them have been. Easy enough. See how those properties work? Good. All right. Okay. So log base 4 of 7 times log base 7 of 64. What do you think about that thing? Any thoughts? Can I use one of those properties? No way. How do I know right away that this problem is not going to be solved by any of those 3 properties we just looked at? Good job. Bases are different. See, that's log base 4, and that's log base 7. No way. The 3 properties that we just looked at, that we will be using on almost everything else, have same bases. Don't they? You must have same bases. So this is not the 3 properties. I'm not going to even think about using those because no way These guys have different bases. This is not one of those. Well then, okay, so what is it? But it's important to realize that first off. It's not one of those. So then what is it? Remember, and that'll be on today's test, remember what we learned. Could you do this on your calculator? Could you find just that first part? Forget about the second part. Could you find log base? Could you get a number? If I just put on the test today, I hope, and I just said, hey, tell me, what is log base 4 of 7? Could you find that?
Yeah.
How do you do it? You don't have a log base 4 button, right? On your calculator, you have 2 log buttons, right? Regular log and natural log. That is neither. Because regular log, as you know, if they don't, regular log of 7, if they don't show any base, means what base?
10.
10, and of course natural log means E. This is log base 4. You don't have a log base 4 button. Right? You just have a log base 10, the normal log, and you have a natural log, which is base E. How do you do log base 4? Or any base other than 10 or E? How do you do them? I'm hoping with one unison, I hope in your minds at least, is a clear answer. Because we had to do some of that with graphing. Remember, we had to do that a little bit? How do you do that? The high goes high, the low goes low. You make it 2 logs. Remember that? You might need that today. So make sure you know that. So it's a good little review right here. So if you have a base other than 10 or E, like 4, anything other than 10 or E, you can make it into 2 logs. Remember? And a lot of times, I've had students in the past get confused on which one goes first or second. So that's why I made the little saying, the high goes high, the low goes low. Because sometimes people go, does the first one go top? Just remember, the higher one goes high, the lower one goes low. That the order doesn't matter. You can't get that upside down. So that's how you do a log of any base other than 10 or E on your calculator, right? Okay, so what? Well, that's exactly what we'll do here. We'll say, well, this is just log 7 over log 4. And this is what? Log 64 over log 7. So I just make them both into 2 logs. And then, and you could just hit the buttons on your calculator, but before you do, look what can happen. These guys cancel, huh? Because now I'm just multiplying fractions. That's just cross-canceling normal fraction multiplication rules. Cross-cancel, right? Just Zippo, right? And so that equals log 64 over log 4. Hit the buttons on your calculator. Isn't it 3? You guys have your calculators with you? I think it should be 3. I know it's 3. So make sure you can get 3 on that. And that's the answer. Is that good? So we never used those 3 properties. We used what you already know about making 1 log into 2 logs. Is that good? Remember we had that on the graphs when I said if you have a log graph and it's whatever, log base 2 of x, and you want to make a little table and plug in some values. If you plug in numbers like 1 or 2 or 3, like put a 3 in here, how are you going to figure log base 2 of 3? Well, you're going to make it 2 logs, log 3 over log 2. That's when we did it. That's when we were graphing those log ones. That's when I mentioned how to make a funny base into 2 logs. So you might need that on the graph today if there's a log graph and you want to find out what values are. That's about it, though. That's about the only time we did that. All right, let's keep moving. So we've got 3. We've got 3 to the log base 3 of 1 minus log base 3 of 4. Okay. That's weird looking. Let's do this. Let's grab this part just by itself and simplify this first off. Just that. Let's simplify it. So what is log base 3 of 1 minus log base 3 of 4? What's just that? Forget about the other part. So what can we do with subtraction? Now those are same bases. So I'm thinking about the properties, right? Same base is going to use the properties. Subtraction, easy job. Adding, subtracting is easy. Easy job for 2 logs. Going to be harder job for 1 person, 1 log. It's going to become what? 1 over 4. It's going to be dividing, right? Subtraction becomes dividing. Harder for 1 log, same base. Okay, so that means all of this. So this becomes 3 to the log base 3 of a 4th, right? This all becomes log base 3 of a 4th. And so then what's the answer? Just 1/4, right? These cancel. Remember how we talked about when the base and the power match, they just canceled. So it's just 1/4. Is that good? On that? Questions? So we're using the properties. So log base 2 of 8x. So notice what they're saying. Write the expression as a sum or difference of logs. So they're saying, take that 1 log and make it 2. Take that 1 log and make it 2. So I'm going to use the property. What is in the middle here between the 8 and the x?
Multiplication.
It's understood to be times, huh? So multiplying for 1 log, a little bit harder operation for 1 person, 1 log, becomes an easier job for 2. It's just going to become adding for 2. Same base, log 2, log 2, log 2. And there we go. That's all they want. Oh, no, probably not. Yeah, no, they want me to simplify this part, yeah. Let me show you about that, and we'll stop with that. So let's simplify that, and we'll be done. So how do you simplify this piece right here? Does anybody know, just off the top of your head, what the answer to that is? What is it?
2 and 3.
No. What you could do is you could turn it into 2 logs. Yeah, that's probably I was going to say something else. Just turn it into 2 logs. Right? The high goes high, low goes low. Hit the buttons on your calculator. The answer is 3. I could also, you know, how I'm doing them. Let me tell you how I'm doing them quick. Not if this is helpful to you. I mean, you could just do that, hit the buttons on the calculator. But what log means, what I'm thinking in my head, if this is helpful to you, log means power needed. Remember, it's reverse power. So instead of power, it's power needed. So when I see log, what I'm saying in my head is I'm saying power needed on a 2 to become 8. That's what log means. I never thought, say that, if that's helpful to you. So when I look at log, I think to myself, power needed. Power needed on a 2. What does 2 need on it to become 8? Well, 3. And that's what it is. That's what a log is doing, if that shortcut helps you. You can just hit the buttons on your calculator. You know, you don't have to do that shortcut. But if you'd like to, that's how I'm knowing the answer, is I'm just thinking power needed on a 2. That's what log really asks, is what power does that 2 need to become 8? That's what logs really do. Instead of giving a power, they ask for a power. Remember, they're reverse. So they ask for the power needed on a 2 to become 8. All right, well, that's enough. We need to take